Hello everyone, welcome you all back. In this video, we are going to solve some two problems on heat exchange between surfaces. So just read this problem. I think in this topic, this is the third problem. Okay. So in this problem, if you read this problem, the first paragraph, this is case 1 and this has to be solved as case 2. Okay. Just read the problem now. The outlet header of a high pressure steam superheater consists of a pipe which is having the epsilon as 0.8 of diameter 27.5 centimeter. So given for case 1, so diameter of the pipe D1 equal to 27.5 centimeter, which is equal to 0.275 meters, and then emissivity epsilon 1 equal to 0.8. Then its surface temperature is 500 degree Celsius. So consider a pipe like this. So the diameter of the pipe is D1, which is equal to 0.275 meters, and this pipe surface temperature is at 500 degrees Celsius. So here it is 500 degrees Celsius, which is equal to 773 Kelvin. Okay. Calculate the heat loss per unit length by radiation if this pipe is placed in an enclosure. The enclosure temperature is 30 degrees Celsius. So it is 303 Kelvin. So this is T2, this is T1. Okay. So write T1 equal to 773 Kelvin, T2 equal to 303 Kelvin. Now you have to find out the value of Q. So Q is, you know the formula, Q equal to epsilon 1 sigma A into T1 power 4 minus T2 power 4. So here epsilon 1 is 0.8 into 5.67 into 10 to the power minus 8 into area is, you know, from the formula itself, the area of the cylinder is 2 pi r L. So here 2 into pi into r value is 0.275 divided by 2. These two get cancelled into length of the pipe is L. So here in the problem itself they are asking to find out per unit length. So L will be 1. Okay, here it is Q into T1 is 773 to the power 4 minus 303 to the power 4. So this value will be, so this L has to come this side. So Q divided by L, that is per meter length value, Q equal to 13.66 kilowatt per meter. Okay. So this will be the answer for case 1. So now go to the case 2. Just read the problem. If the header now is enveloped in a steel screen of diameter 32.5 centimeter. So in the case 2, this is the initial pipe of having diameter D1. Now this pipe is enveloped by a steel tube. This diameter is D2 equal to 32.5 centimeter, which is equal to 0.325 meters. Okay. And the steel screen emissivity is 0.7. So epsilon 2 equal to 0.7 and the temperature of the screen is 340 degrees Celsius. So, and then find the reduction in heat transfer due to provision of this screen. So in the second case you have to substitute D2 as 0.325 meters and this is epsilon S. Screen emissivity is 0.7 and the screen temperature Ts equal to 340 degrees Celsius. Now you have to find out the value of heat transfer per unit length and then it is how much it is reduced from this value, that is you have to find out, right? So case 2, write down T2 equal to 0.325 meters and epsilon S equal to 0.7, Ts equal to 340 degrees Celsius, which is equal to 613 Kelvin. Okay, now you know that Q equal to epsilon dash sigma A, because a screen is added here. So sigma dash into epsilon A into T1 power 4 minus T2 power 4. Now you know that Ts equal to T2. Okay. Now here it is a concentric cylinder problem, no? So now epsilon dash, the formula will be 1 divided by 1 by epsilon 1 plus A1 divided by A2 into 1 divided by epsilon 2 minus 1. So if you substitute all the values here, so the A1 value is 2 pi RL, A2 value is 2 pi R2L. So here 1 divided by 1 divided by 0.8 epsilon 1 plus A1 is 2 pi R1L divided by 2 pi R2L. So here 2 pi gets cancelled, L gets cancelled, and R1 divided by R2 into 1 divided by 0.7 minus 1. Okay, so substitute. So calculate, if you calculate all the values, epsilon dash will be 0.62. Now substitute this epsilon dash value in Q equation. You will get 0.62 into 5.67 into 10 to the power minus 8 into area value is 2 pi RL. So 2 into pi into 0.275. So because the heat is exchanged from the inner surface, so here you have to substitute inner surface diameter into length. So this is diameter, so I have to substitute in radius into L to the power 773 power 4 minus 613 power 4. Okay, you will get the final answer as 6.55 kilowatt per meter. So Q divided by L. For case 2, this is in the problem, you are asked to find out the reduction value of the heat transfer due to the addition of this screen. So reduction in heat transfer is equal to 13.66 minus 6.55, which is equal to 7.11 kilowatt per meter. So this will be the final answer. So Q divided by L value is. Now go to the next problem. This is the fourth problem in our series. So I am writing 4. Two concentric spheres of 30 centimeter and 40 centimeter in diameter with the space between them. So a sphere of having 30 centimeter diameter and 40 centimeter diameter. So this is D1, this is having D2. The space between them, this space is evacuated, the space between them evacuated are used to store liquid at minus 130 degrees Celsius in a room at 25 degrees Celsius. So the room temperature is 25 degrees Celsius. So here it is minus 130 degrees Celsius. Okay. The surfaces of the sphere are flushed with aluminum of epsilon equal to 0.5. So here it is polished with aluminum. So emissivity equal to 0.5. Calculate the rate of evaporation of this liquid if the latent heat of the liquid air is 220 kilojoule per kilogram. So write the given data. Given first thing, D1 equal to 30 centimeters, which is equal to 0.3 meter. Similarly, D2 equal to 0.4 meters. So R1 equal to 0.15, R2 equal to 0.2. Okay, then T1. So T1 is minus 130 degrees Celsius, which is equal to 143 Kelvin. T2 is 25 degrees Celsius, the ambient temperature. No, T2 equal to 25 degrees Celsius, which is equal to 298 Kelvin. Then the latent heat HFG value is given as 220 into 10 to the power 3 joule per kilogram. It is given in the kilojoule per kilogram, right? So now to find rate of evaporation, it is nothing but Q value you have to find out. Now you know the formula. Q equal to epsilon dash sigma into A1 T1 power 4 minus T2 power 4. Now this epsilon dash value is nothing but 1 divided by 1 by epsilon 1 plus A1 divided by A2 into 1 divided by epsilon 2 minus 1. So substitute all the values here. Here the area value is 4 pi r squared, right? A1 is 4 pi r1 squared, A2 is 4 pi r2 squared, right? Substitute all the values, you will get epsilon dash as 0.032, okay? This value has to be substituted in this equation in order to get the Q value. So Q12 equal to 0.032 into 5.67 into 10 to the power minus 8 into 4 pi r squared 0.15 squared T1 power 4 143 to the power 4 minus T2 power 4 is 298 to the power 4. So you will get the answer as minus 3.83 watts. So this is amount of heat liberated. So now rate of evaporation has to be find out. So it is nothing but heat transfer divided by latent heat. So it is derived from the formula Q equal to m dot into HFG. Here m dot equal to Q divided by HFG. Substitute the value 3.83 divided by 220 into 10 to the power minus 10 to the power 3. You will get 1.74 kilojoule per seconds. So this will be our final answer. Thank you all. In the next video, we will solve the problems on radiation shields.